This is the third part to 1.6. We're now going to be solving radical equations. So we solved by factoring, solved rationals, now we're doing radicals. But before we get started, just a quick review on how to solve by completing the square. Remember, when we're completing the square, we're always going to move c to the other side first. So we have x squared plus 6x. We're going to add that 1 over. Then we're going to take our b value, divide it by 2, and square it. We're going to add that number to both sides, so that equals 9. So we're going to add the 9 to the left and to the right side. We then factor the left side. It always factors to x plus half of b squared. And then to solve, we take the square root of both sides. So that gives us x plus 3 equals plus or minus the square root of 10. And then we have to get x by itself and see if there's anything else we can reduce. The negative 3 has to go before the plus or minus. 10 does not have a perfect square that goes into it, so we do not have to simplify that anymore. Okay, so let's get into some radicals here. As always, I would encourage you to pause a lot, get things written down, and then come back. Try not to be scrambling to write everything down and listen at the same time. Pause, write it down, and then come back and hear the explanation. So one thing you want to keep in mind when you're solving a radical is always isolate the radical. Okay, so before we can do any solving, we want the radical to be by itself on that side. So isolate the radical. So on number 1 here, we want to start by getting rid of that negative 3. So we're going to divide both sides by negative 3. So we have 4x minus 3 equals 4. And then we want to get rid of the radical. So this is a square root. To undo a square root, we would square both sides. So we have 4x minus 3 equals 16. And then we just solve normally now. Add 3 and divide by 4. So x equals 19 fourths. Now this next one is not going to be a square root. Instead, it's going to be a cube root. But the first step remains the same. We still want to isolate first. So we're going to start by subtracting 5 and then dividing by 2. So pause. You can see if you can do those 2 steps. And then come back. So we're going to subtract 5. So we have 2 times the cube root of 4 minus 3x equals negative 14. Then divide by 2. So cube root of 4 minus 3x equals negative 7. All right, now we want to get rid of the radical. Last time it was a square root, so we squared both sides. This time it's a cube root, so we're going to cube both sides. When we do that, that eliminates the radical on the left side. And then negative 7 cubed is negative 343. And then we just finish solving normally, getting x by itself. So subtract 4 and divide by 3, which gives us x equals a positive 347 thirds. Notice that I'm leaving my answers as fractions. That is really important, especially when you get a fraction like this one that could give you a repeating or non-repeating, but infinite decimal. That would be ugly. So try to remember to leave your answers as fractions. All right, let's take a look at another radical. This time we have a radical that's inside a fraction, but just because it looks different, we don't change our steps at all. We still want to isolate and then get rid of the radical. So after you write it down, go ahead and see if you can do those 2 things. Hit pause and then come back and see if you got the right answer. So to isolate, we need to get rid of the 4, so we multiply both sides by 4. So we'd have cube root of 5x plus 2 equals 20. And then we need to cube both sides because it's a cube root. So cube the left and cube the right. on the left, we'd have 5x plus 2, and on the right, 8,000. So then we can solve that to get 5x equals 7,998. And then, of course, to get x by itself, we divide by 5. So x equals 7,998 divided by 5. Now, if you were actually to divide that by 5, the decimal isn't an ugly one. It's a nice terminating decimal. So either one of those answers would be okay. But if it is a repeating or non-terminating decimal, then you need to leave it as a fraction. All right, number 4. Again, we want to isolate the radical, but we're going to get a little different scenario going on this one after we do that. So start by getting this radical by itself, so subtract 2. And then, just like we have done on all the others, we're going to get rid of the radical. This is a square root, so we're going to square both sides. So on the right side, we have 3x minus 2, just like we always have. But on the left side, instead of a single number, we have a binomial. So to square it, you have to FOIL it. Squaring means writing or multiplying it by itself, so we have to write it out twice. So we have to take x minus 2 times x minus 2. So that, when we multiply it out and simplify, we get x squared minus 4x plus 4. And then we can combine like terms. So we'll get everything to one side. So we have x squared minus 7x plus 6. And after we've moved it all to one side, we have to solve this quadratic. So we can solve it in lots of ways. We've learned how to solve by factoring, by completing the square, by quadratic formula. But I think factoring is definitely the easiest. So we will factor this to x minus 6, x minus 1. And then set each one of those equal to 0 and solve. So we know that x could equal 6 or x could equal 1. Now the thing on these is you have to check to see if one of them is extraneous or not. Because they both could be extraneous, they both could work, or one of them could work and one couldn't. So we have to check these. So let's check x equals 6 first. So that means we're just going to put the numbers back into the equation. 6 equals the square root of 3 times 6 minus 2 plus 2. So we have 6 equals, oops, that plus 2 is outside. 18 minus 2 is 16. So square root of 16 is 4 plus 2. Okay, 6 does work. Yay, 6 equals 6. So that's a good one. We can keep her. That one. But now we need to try x equals 1. Substitute 1 in for all the x's. 3 times 1 minus 2 plus 2 on the outside. 1 equals square root of, let's see, 3 minus 2 is 1. All right, so square root of 1 is 1. 1 plus 2, though, is 3. Obviously, 1 does not equal 3, so that means that x equals 1 is extraneous. You will have to note that on your homework and your tests. So you have 1 that does work, and then 1 that does not work, but you have to show both of them and show that the one that doesn't work is in fact extraneous by putting a line through the equal sign and writing the word extraneous.